In these examples, we're going to study the affinity mapping in the shape machine, and we'll start by drawing two parallel lines that will connect to define a parallelogram drawn in Rhino, and we'll inscribe a second parallelogram inside the first by connecting the midpoints of the outer parallelogram. In the top left corner, we'll draw a smaller template shape that's related to the larger design on the right by affinity because they're constructed in the same way. So because the smaller template on the upper left and the parallelogram design on the right are related under affinity, their parts should be related too, which we can confirm with the shape machine. So we start by drawing this pair of triangles in a facing relationship with an open space in between them. And when we search under affinity in the shape machine, it can find the two variations of that relationship that are embedded in the parallelogram figure. And we can search for anything that we can see embedded in the template to check these relationships under affinity. So what about these two touching triangles? The red highlight shows the matches of the shape we search for on the left as related under affinity in the larger design on the right. And we can search for shapes that aren't specified by closed polygons too, as long as they're embedded in the reference shape. We can find them under affinity embedded in the design on the right, like this open R shape. So what about an open polyline? We can draw one that we want to inquire about on the reference shape. And under the affinity mapping in the shape machine, it can find all the matches that are embedded in the design. And when we find one that we want, we can select it, cut it, and pull it apart from the design. Basically, any shape you want to draw on the template can be found under affinity. So in this case, we have the sigma, and the shape machine can find the corresponding parts in the design. So what about this three-lined figure, kind of A at the corners? Under affinity, it can be found at the corners of the design too. And we can also shorten one of the legs of the A to define a shape search where the geometry isn't restricted to shapes that meet a vertex in the larger shape. And some arrangements have some bizarre mappings under affinity, like this arrangement of two open facing L's. It's embedded in the shape in three different ways, in the way we specified, and also in two different variations with the same spatial relationship under the affinity mapping. So in all, there are 3 different types of the 2 L's embedded in the nested parallelograms. And we can search for arrangements of floating lines too, like these 4 in a cyclic symmetry. And the shape machine can help us see how this arrangement maps to both the smaller parallelogram and the larger parallelogram under affinity.